Alright, welcome to our video that covers some of the stuff from the coordinate geometry. So it's a revision for the exam. This particular question is actually a series of questions, and all of them are taken from a previous Year 10 half yearly. So let's have a look. So I'm going to deal with the coordinates of these 4 points first. Now as we look at Z, we find that it is level with two numbers, 1 here and 2 there. Now with coordinates you always put the number that it's level with on the horizontal, the x-axis first. So level with -2, so we do a bracket, -2, comma. Also level with 1 on the vertical, the y-axis, so there's 1. And there's the answer for that one. X coordinate -2, y coordinate 1. D, over here, level with 3 on the horizontal, -2 in the vertical. P is level with -4 in the horizontal and -3 in the vertical. Q up here, level with 2 on the horizontal and 3 in the vertical. There's our answer to part A. Okay, next bit is the distance from P to Q. So what I'm going to do is draw the line P to Q first. That will be the distance of that red line. Now, what we have to do first then, after that, is make a right angle triangle with that red line is the, hypotenuse. Going to work this time. Yep, good. Here we are, right angle triangle with the red lines of hypotenuse. Then, okay, that's our first step. Next one is to measure how long are each of these black ones. And we'd count the numbers. We're starting at -4 and going to 2. So that's 1, 2, 3, 4, 5, 6. So I'll go 6 for the horizontal. And how far for the vertical? Goes from -3 to +3. 1, 2, 3, 4, 5, 6. 6 in the vertical. Now that, then you have to go back to revise Pythagoras, because that's the way to work out the distance here, because that's the hypotenuse. So we'll go PQ squared equals 6 squared plus 6 squared. Now 6 squared is 36 and 6 squared is 36, and that equals 72. So using Pythagoras, PQ squared equals 72. And all we do is cancel out the squared by doing the opposite, which is square root. So I'll just squeeze it in over here. PQ then, distance. Now I've got rid of the squared, I've got to get rid of the, reverse that on that side, square root of 72. Answer. So I'll just do that again. 1. Make a right angle triangle that joins up PQ with the hypotenuse. 2. Distance of the horizontal. 1, 2, 3, 4, 5, 6. Vertical, 1, 2, 3, 4, 5, 6. Use Pythagoras. P skew squared equals 6 squared plus 6 squared. 6 squared 36, 6 squared 36. Add them together equals 72. So now P skew squared equals 72. That means PQ equals the square root of 72, because that's what happens when you cancel a squared. You have to do the reverse, and that square root is the reverse. So that length there is the square root of 72. If you did it on a calculator, it would be around about 7, 8, 8.5. Okay, next one. Coordinates of the midpoint between Q and D. Okay, Q is 2, 3, and D is 3 minus 2. Okay, I'll just put them side by side because that helps to work out the midpoint, because what we need to do is work out the average of these two. When you work out the average of these two, you're going to get halfway point. Average of these two, halfway point. So, average adding up and divide by 2. 2, so add these two. 2 plus 3 is 5. 5 divided by 2 is 2.5. And then 3 plus minus 2, that's 1. And divided that by 2 is a half, 0.5. Okay, so add the 2 up, divide by 2. 2 plus 3, 5, divide by 2, 2.5. 2 plus minus 2 is 1, divide by 2 is 0.5. And just to check, between Q and D, midpoint is 2.5, which is there, and half, which is there. Oh, yep, that makes sense. Looks step halfway between Q and D. Tick. Okay. Next one. Gradient of the line that would join Z to D. Well, I'm just going to have to get rid of some of this other stuff because it may get a bit confusing. So we'll delete that one. We'll delete that one. And I'll get rid of that one. Okay, because what we're going to need to do, gradient, is using the same idea as distance. Z to D. Z to D. Here we are. That's the gradient of that one. Gradient being slope. Okay, let's go there. Gradient equals slope. Which is measured by rise over run. Okay, let's now, so just like the distance one, we make a right angle triangle. Using the red as the hypotenuse. There we go. And there we go. Right angle triangle. Oops. What the? I'll try that again. Okay, now we're right. Okay, right angle triangle. There. This one's actually easier than the distance one. Okay, let's go there. Get rid of that. Okay, so rise is this far. So since we're starting at one level with 1 and ending up level with -2, and we're going down, so the rise is actually minus because we're going down. 1, 2, 3. If the line was going that way, it would be plus. Going that way is minus. -3. That's the rise. going down. 1, 2, 3. Run starts at -2 and ends up at 3. That would be 1, 2, 3, 4, 5. That's the run. Answer, gradient is -3/5. Okay, that's that one. Lastly, equation of line passing through Q and Z. Might use a different colour this time. Q and Z, straight line. Equation of that one. Here we are. Equation of that one. Okay, and I've wrote this here earlier just to help me out because this is the equation with our general equation. Now, for a line, now we have to be specific for this particular line. Now, so the plus b part first, because that's the easiest bit. I'll just put y undo y equals. I'll leave that a little bit blank. The plus b is whereabouts on here. That's called the y-intercept. Y-intercept is there. That's the plus b. And for this line, it's at +2. Here we are. First bit of the equation. Is the plus b is our +2 because it crosses the y there at +2. Now, m, so b equals y-intercept. The m is gradient. Now, I'm just going to do this quick without drawing anything. So let's see if we can do rise over run, because that's the gradient from z to q to z. We're going up, so it's a plus gradient. Okay, and then we've got a, what's the rise? It starts at 3 and ends up down at 1. So 1 to 3. That's 2. Rise is 2. Going up. And the run is 1, 2, 3, 4. Okay, 2/4. Okay, we can simplify that to a half. So I'll do that. 2/4, rise over run. No, we're just gonna simplify it. Half is the gradient. And then all that's left is put the x there. Done. That's the equation of that line. Thank you.